But let's get started because otherwise I will run way over schedule, and I'd love to get enough time that we can do some good Q&A because that's always the fun in the breakout. So this is the agenda. I'm not going to read it. So what are customers asking me, at least, when they're asking for storage infrastructure for private cloud? In other words, stuff behind vSphere, right? Now this is going to have a bit of an EMC tinge on it, but I'm going to try and also describe it in more generic terms as well because there's people here who are not EMC customers, right? So what they're asking for is they want infrastructure that gets out of the way and accelerates virtualization projects as opposed to slowing it down. One of the big common complaints there is complexity of storage gets in the way. Sometimes getting the storage team to who here is the storage team person? And are those people holding their hands up also the VMware people? Right? So when you're both people, that's one thing. When you're larger, a lot of customers complain about the interaction between the VMware team and the storage team, the rigidity in that kind of model. So vCenter integration is really, really important, and there's a lot of work being done, not just at EMC, but across the storage vendor landscape there. The other thing is that they want efficiency throughout the whole stack. They want efficiency to also apply. They're trying to lower their CapEx costs, and the cost of storage is sometimes an inhibitor to virtualization, right? I did that survey on my blog, and you could see, that was one of the main things that people said, yeah, that's a challenge. And then the last thing is they want the storage to not only be integrated from a UI standpoint, they want it to be an extension of vSphere more and more, right? So if you saw in Paul's keynote when he said, we're going to do orchestration and management and down the compute, networking, and storage side, the stuff that came out in VAI that we'll be talking about, that's just the beginning, right? There's going to be a VAI version 2, right? And there's other things coming in the future vSphere releases that are targeted at more and more tight coupling of policy and execution. So where does storage integration happen with vSphere? So it happens in the following places. So the first one is plugins for vCenter, right? If your storage vendor doesn't offer a vCenter plugin, it might be time to look at a different storage vendor, right? They don't take a lot of time to develop. They don't take a lot of time to build, right? I mean, there's good ones and bad ones, right? But if a storage vendor hasn't built one by now, like, holy smokes, maybe VMware isn't their priority, right? That's maybe a signal. The other way is, and this is earlier days, but can the array itself integrate into vCenter from the bottom up, right? Because in some places, there isn't the one team storage / VMware person, and there's a storage team. The storage team needs to understand the relationships to VM objects. And the other thing is around extensions to the VM kernel itself, around multipathing and things along those lines. For a while, EMC was the only one that had a multipathing plugin in PowerPath VE. And PowerPath VE previously had a dependency on Enterprise Plus. If you didn't see in vSphere 4.1, that got lifted. You can be Enterprise or Enterprise Plus and be able to use PowerPath VE. But we're not alone there. Dell EqualLogic recently has GA'd their multipathing plugin. These change the underlying behavior of the VM kernel when it comes to multipathing of I/O. The other one is the vStorage APIs for data protection, which uses a series of things to allow us to crack open the VMDKs, see the contents, do a single-step file-level restore. Those are used for backup apps, but they can also be used with array snapshot techniques, right, to allow you to back up the whole VM but restore stuff inside the VM. And obviously, Site Recovery Manager. Do we have any Site Recovery Manager customers? How's it going? What's that?
We're just starting.
Just starting. Site Recovery Manager, how's it going? Good. That's fantastic. So in production, doing failover tests. Site Recovery Manager makes DR, which was previously a very complex thing, much, much easier. It's actually one of VMware's most successful products outside vCenter and ESX. There's now like 3,000, almost 4,000 customers globally. Very popular. And in the early days, the Site Recovery Manager adapters varied a lot from one vendor to another. I still think that, again, maybe I've drunk the Kool-Aid a little bit. We do a very good job of supporting, revving them, support for vSphere 4.1, all of that sort of stuff. But as a whole, I think the storage community has embraced it pretty well now. And then the other thing is this VAI stuff, so the vStorage APIs for array integration. Has anyone heard of that before? Right? We're going to be talking about that a little bit. I know that there's so many acronyms and so many things like that that some of you will have heard it. We're going to dive into it a little more in detail. One thing that is another interesting thing is future NFS offloads. So currently VAI is block only, VMFS only, right? Well, RDMs as well, but block only. NFS support is something that we're working on pretty furiously. Just out of curiosity, how many of you use VMFS predominantly versus NFS? So VMFS, raise your hand. NFS? How many use both? Yeah, I think both is a very happy place, right? If you come to the session where we're talking about things that I'm doing with my respected colleagues from NetApp, we're heavily trying to say, hey, look, there's goodness in both, right? And then there's a lot of cooperative development that goes on in the VM kernel between the storage community and VMware around the data mover code, which is the thing that actually moves giblets of stuff around, as well as the NFS client itself. Okay, so let's talk about vCenter plugin integration, right? So this is all shipping GA stuff, and I actually don't know of any storage vendor that's charging for their vCenter plugins. Speaking on the EMC side, everything you're about to see here is free. Is anyone using their EMC plugins for vCenter? How's it going? It works? Does it help? Good. Now, they're not perfect, right? Not perfect. And we're going to, if you go down to the booth, we're previewing the next rev, which is a lot of good improvements. So the idea here is to enable self-service for the VMware administrator, right? Make it easier for them to be able to provision everything on their own. And we can now do this across every EMC platform at every scale and every protocol, right? iSCSI, FCOE, NFS, and we can do it on the small arrays, on the big arrays, all together. So let me just move this out of the way. Obviously, familiar home, right? vCenter. There's an EMC storage button. On this one screen, you can provide the credentials to all of the arrays that you may have, and it supports the SIM stuff, mid-range stuff, and NAS stuff. The storage team would give you a read-only credential, right, to be able to query stuff against the array. Now, if you go in and you take a look, what does that mean? It means that directly from within vCenter, you can go in and there's an EMC storage tab, and if you're on a data store object or if you're on an ESX host, it shows you the relationship of that data store with the underlying where is it on the array, right? What is it in array vendor speak, right? Because in VMware speak, it's VMHBA numbers and things like that, right? So here you can see where is it on the array, how is it configured, is it virtually provisioned or thin provisioned, is multipathing set up? And this is on an NFS-based data store. So normally on an NFS data store, all you kind of see is the IP address and the mount. Right here you can see all sorts of details about the actual utilization on the back. You can see all sorts of details around how it's being consumed. Now, visibility is good. That's something we've been doing for a while. People wanted provisioning, so let me actually change stuff, right? So what we've added is the ability now, and it's been GA for some time, is the ability to provision storage directly from within vCenter, right? So let's see what that looks like. So we're going to do it first on a VMFS use case. So normally, what the storage person would do is they'd carve out LUNs, mask it, all that stuff. VMware team basically rescans, puts VMFS on it. Here you can see what we're going to do is we're just going to say, give me a data store. I need it to be this big, and I am going to put it on this pool, right? So you're not saying exactly where it's going to go. We're moving towards provisioning models, which are much more abstract, right? So boom, as soon as you hit go, it's going to do all the stuff on the storage side. So it's going out and it's actually provisioning, in this case, the EMC unified block model, right? And then it's going to present it up to every single one of the ESX hosts in the cluster. So the larger the cluster, this becomes more and more useful, right? Those tasks, normally you have to go around from node to node to node. And then eventually it's going to create the VMFS volumes on top of that, right? So much, much simpler. A task that normally would have taken a lot of stuff is made easier. If you want to do NFS, I want to show, again, I'm strongly encouraging people to give it a shot, play with it, learn, explore. You can download the Solera virtual appliance off the internet, right? By the way, hint, it never times out. You can add as much storage to it as you want. Hint, hint. So, it's a great way to build yourself a huge Solera that runs as a VM. In any case, the Solera presents it's an NFS server, so it'll present out the NFS Exports, here, likewise, all you're going to do is say, I want it on this data mover. It's got like a scale-out model, so you can have lots of brains inside it. I'm going to put it in this pool. So again, you can see we're moving towards pooled provisioning models. And then I'd like it to be initially this big and eventually grow to this big, because in the NFS use case, it can grow dynamically on the back end side, right? The other thing that's important is it sets all of the ESX advanced properties that normally most people miss. And those advanced properties are very, very important. If you don't do it, you'll eventually have a very bad day based on how NFS servers fail over, right? That's true of the Solera. It's true of all NFS servers to varying degrees. And here you can see likewise, it's going to distribute this across every node in the cluster, right? So every one of them is going boom, 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 new data store appears. Simple? Was that simple? That's simple, right? And again, we're trying to enable that so the VMware admin can do it themselves. So the next thing that we're going to do, I want to show, is that the plugins have moved beyond basic provisioning even, and now we're letting the VMware administrators leverage advanced array capabilities without needing to be the storage person. So on the arrays, you have the ability to create snapshots, large numbers of snapshots. And on an NFS-based data store, you don't snapshot the data store, you can actually snapshot a file, right? So here what I'm doing is I'm taking a VM, and I'm saying, okay, let's deploy it inside that DRS, the resource pool. Let's create 50 copies. Notice it says 473. That's a weird number, right? That's not actually the max. The maximum is 65,000, right? That we can do on an NFS-based data store of a single VM. It's actually looking at the number of cores you have in that cluster to avoid, doing something that might not be smart. Right? So it's not the array limit, it's how you want to do it on the cluster. The key thing here is that each one of these is just a pointer-based copy. Very, very fast. And here I'm basically deploying them at a rate of like 1 a second. Normally cloning those would take more time, right? So we're exposing that functionality up directly in the VMware use case. Again, I don't want this to sound like an EMC commercial, but these are the sort of things you should be looking for storage inside virtualized context from your storage vendor. Right? The other thing that I think is cool is that we're expressing things like our compression capabilities. So we can compress now primary storage. Who here has an iPod? Everybody, right? Come on, like seriously. A digital camera? When you think compress, don't think zip. It's not like a zip. It's more like when you hit play on your iPod, it's an MP3, right? It doesn't say decompressing. Here you can see that we've compressed a VM, and on top of being thin, we're reclaiming about another 27% worth of capacity, right? So it adds a little bit of read latency, relatively small, about 10%, but you can save a lot of capacity, and there's no write impact. Now, as we threw this out there to very large customers, their storage teams freaked out and said, thou shalt not give the VMware tool to that team because that would be bad, right? So what they asked us to do is to say, let us create a fenced-off pool, right? That is a fenced-off pool not of just disks and capacity, but also brains and ports and cache, so that there's, that the VMware team can only screw themselves up, right? Not the mainframe that's also attached. So what happens is that you'll notice that they created pools, and then the VMware team can then sub-allocate those pools themselves. So the storage team says, I'm going to give you this much every 6 months, and it's thin, so they're not being consumed, right? And then the VMware team can go, okay, out of that capacity I got, I'm going to give this amount to this cluster, I'm going to give this amount to this cluster, I'll give this amount to this DRS resource pool, that sort of thing. And that means that you can self-provision, but the storage team is happy because they've fenced you off, right? Again, in the mid-size market, it's not as big a deal because sometimes that array is the only thing, the only thing attached to it is VMware, and they're cool with it. But if there's lots of other stuff attached to the array, generally they're less cool. So if we've made good progress, I wouldn't say we've solved the problem of the VMware person. How do we make the life easier for the storage person? The answer there is to integrate the storage UI directly into vCenter. So what that happens is this is home for a EMC storage administrator. This is Unisphere. We've merged together our NAS and block management. It's simple, easy, and fast. And hit that virtualization button. Basically what it does is you connect via the vCenter API, and automatically ESX host populate in this list. And what's cool is when you click on the ESX host, it tells you what VMs are on it, right? So the VMware administrator, the storage administrator is now getting VM object level awareness. This is really important. Like if there's ever a problem, maybe they know about it before you as the VMware team does. This allows them to go, what VM is affected, right? Here what I'm doing is I'm saying, hey, show me the details. Inside that storage thing, there's those individual VMs, and that VM has those VMDKs that are consuming this amount of capacity. This can all nicely be exported as a report, right? So again, I think one thing that is cool is the integration is happening in both directions. We think that solving this for both users is a very, very important idea, right? Being able to solve it for both the VMware person and the storage person. Does that make sense? And I think you should expect to see more and more innovation down this path, not just from EMC, but from many. Does it make sense? Did I say that this was free? Right? So why wouldn't you? If again, EMC customers, raise your hand. Why? Please download it. If it's pretty straightforward. And give us feedback. Right? The developers for that tool are actually down in the booth. So if you want to talk to them, give them input. What's next? It's a great opportunity for us. Right? Our job is to support you guys. Okay. Next, VAI, vStorage APIs for array integration. vStorage APIs for array integration are what Intel VT did for compute, hardware assisting the MMU function in vSphere 4. In other words, doing stuff in hardware that was previously done in binary translation and other modes, up in the VM kernel. This does for storage. So it has 3 APIs. The first one is hardware accelerated locking. What this does is that today, if you're on any version other than vSphere 4.1, and if your array doesn't support this VAI stuff, this is what happens. Whenever you create a file, delete a file, change anything in the VMFS file system, vMotion, VMHA, all that stuff, there's a momentary period where as it updates the metadata on the VMFS volume, it issues a SCSI reservation, right? And while the SCSI reservation is held, no IOs can happen to any other ESX host in the cluster. This is one, not the only one, but one of the things that is a determinant of cluster size and number of VMs per data store, all that sort of stuff. Now, for most customers, this is normally invisible, right? And it's actually a good thing, because that's the thing that allows VMFS to never have any issues with, locking of files. Otherwise, these distributed file systems normally involve lots of complexity and metadata managers and all that sort of stuff. VMFS doesn't ship with a manual, you know what I mean? So it's pretty simple, right? But the problem is that in cases where there's loads of metadata updates, there's performance impact to the adjacent hosts in the cluster. Does that make sense? So we worked on this one, and what's changed is this. So now the locks occur at the extent level. So in other words, the only thing that gets locked is the stuff that's being updated, not the whole LUN. Does that make sense? So if you take a look at this, the behavior then goes, hey, just update the metadata. There is no impact on the adjacent hosts. In fact, as we're trying to do all the marketing, stuff, hey, we support VAI and that sort of stuff. We wanted, the marketing team wanted to make it really simple. It makes everything 10 times better. Well, the real thing is to say it makes most things 2 times to 10 times better. But in this one, 10x is actually low. We moved from the safety zone being 40 to 60 VMs per data store to being there's no fundamental scaling limit on the number of VMs and metadata updates on a data store anymore, right? So it'd be more correct to say it's infinitely better, right? The places where this matters the most are these use cases. Big clusters with loads of VMs, right? View cases, right, where lots of things are being booted, all that sort of stuff. The bootstorm scenarios. One of the aspects of bootstorms is metadata updates. Lab manager use cases, things like vCloud Director, where things are being built, torn down, moved, all that sort of stuff, much more dynamically. Also, more and faster VM-level snapshots. The other thing that is not in the marketing, but you come to VMworld to not get the marketing, right, is that there were cases where people had a SCSI reservation that never got let go. Has anyone ever had that one? Not a happy day, right? So the SCSI reservation mechanism, it was never really planned to have this degree of intensity that happens in a really busy cluster, right? This is a much, much more lightweight set of SCSI commands, which means that it's much easier on both the ESX host and the storage array. So testing's suggesting that it's also much more robust fundamentally. Make sense? This is all done via SCSI standard commands. So there's something called a atomic test and set. Compare and swap is the non-engineering version of that, right? Does that make sense? Very, very cool. The cool thing again is that it's invisible. Like just like Intel VT, you don't have to do something to turn it on. If your array supports this, you're good to go. Hardware accelerated 0 is the next one. So what happens here is that if you guys are an ESX host and I'm a storage array, anytime that no matter what type of VMDK you've got, whether it's zeroed thick or thin, right? The only exception is an eager zeroed thick VMDK. Every time that you write to a new allocation, the first thing you do is you send me a bunch of zeros. And then you follow up and you send me the data, right? So what that looks like is like this. If you listen on the wire, you'd see SCSI write 0, SCSI write data, SCSI write 0, SCSI write data, right? Over and over and over again. It's not uncommon if you listen on the wire, and this is true whether it's SCSI, fiber, FCOE, whatever, you'd see 20, 30% of the traffic being just, in essence, sending nothing. But it actually is nothing that weighs a lot because it actually consists of real payload, right? So what's changed is with the API, the command looks like this. SCSI write same, do a whole bunch of work for me, and then data, right? What this means is a lot less traffic on the wire. How much less? 20, 30, sometimes more than that. It also means that the operations are much faster, and there's less load on the array and on the ESX host. So again, what are the use cases? Reduce the I/O workload, make things happier and better, particularly in FT-enabled VMs. The last one that I think is probably the sexiest, and if I think this is sexy, I mean, I'm clearly a nerd, is hardware accelerated copy. What this does is it says, if this side is ESX host, right, and I'm the array, again, I'm going to use you guys as an example, and you say storage vMotion in this VM array, you go, okay, great. You then read the entire VMDK. Let's say the VMDK is 100 gigs in size. You read all that data. It goes out across the wire to you. And then what you do is you write it out back to me, right? Clearly not efficient. And who here has used storage vMotion? It's awesome. Awesome. When you do it, it's not disruptive, except for the fact that it will swamp your network and the array while it's running, right? So there's a performance impact to the other stuff while it's going on. And the thing is it doesn't have a throttle. So it'll read and write the data as fast as it can possibly go, which means it'll saturate whatever pipe you have. Right? If you're on giggy, 10 giggy, 4 gig, 8 gig, it'll fill it, right? As long as the array can fill it. So it looks like this. Again, clearly not as efficient as it could be. So what has changed? Basically, it issues a single command that says, that set of blocks, that represents the VM. Can you make a copy and just tell me when you're done? Right? So that's a huge, huge offload. And so I think this one here is very, very useful. It applies to deploying things from templates. It applies to storage vMotion operations, all that sort of stuff. So what does it look like? And what's kind of cool about this is you'll see some of the innards, right? And I don't have time to demonstrate all 3 of the APIs, but if you want to see them, you can do it in the hands-on lab in the booth. What we've got here is we've got a vSphere 4 host. You can see we've got a couple of data stores sitting on a CX. That warning is actually a storage I/O control threshold, right? Pretty cool stuff there as well. And down here on the array, again, boom, this is what it looks like. So if we go and we take a look, what I'm going to do is I'm going to intentionally turn off the feature, right? The feature by default is on, right? So if we go and we take a look, by the way, this is the VM that we're going to be moving around. It's this, look at, this is real. This is a 75 gig VM, right? In the advanced properties on the ESX host, you can see the setting. And by default, it's set to 1, which means on. And what that means is it queries the array, hey, are you cool, and can you do this hardware assist? And if the answer is no, I'm going to default back to the oldie-timey way. But it's by default on. And what we're going to do now is we're going to say, okay, let's do storage vMotion, right? I've turned off the feature, remember, so this is the current state, not future state. We picked the other data store that we're going to move it to. By the way, the reason the storage I/O control, how terribly rude of that. Who leaves their phone on? Oh. You can see that as I move it, the throughput in commands per second, those are SCSI commands per second, and megabytes per second, is going to climb through the roof. We're now doing 160 megabytes per second, and it's going to peak basically at 260 megabytes per second of stuff that's being transmitted during this storage vMotion with 5,000 commands per second. That's real work for the ESX host. It's real work for the array. And the network is swamped, right? So if we now go and say, okay, how long did that take, right? The actual time that it took was, roughly around 12 minutes, right? Now what we're going to do is we're going to turn it on, which is really the default, right? And do the exact same thing. Do a compare and contrast. So you go into that advanced property. One thing that's cool is all of these VAI things, you can change the setting without doing an ESX host reboot, which is nice. By the way, if your array supports VAI, it'll show up as hardware acceleration supported in the data store view. So we'll do the same task. We'll move it in the opposite direction, do a compare, and see the before and after. And I think it demonstrates pretty clearly why we think this is a big deal. So off it goes. We'll pick the other data store, and you're going to quickly see the effect. So if we take a look again at the ESX top counters, boom, commands per second, nil. Why? Because it issued one command, move this set of data. Traffic on the wire, 0, right? Because nothing's being transmitted between the ESX host and the storage array. It's all being done internally, right? So you can see also that the time it took to do the task is shorter. It's about 8 minutes. So that's about a 25-30% improvement in time to do task. On other arrays, so this is our mid-range array, on a VMAX, the task is actually 10 times faster because it actually says, don't worry about it. I'll take care of it after the fact, right? And can defer the copy. Now, this is what it looks like to the array in terms of the brain utilization. So in other words, how hard is the array working? Well, you can see the storage vMotion almost completely maxed out the brain of the array, right? We're kind of exposing some of our own dirty laundry here, right? Of course, I did this on a little tiny baby array. But you can see that the actual load on the brain of the array is significantly lower and the time period is shorter. So roughly about 50% less work for the storage array itself. And the same thing holds true on the ESX host side. Now, before we take a look at the ESX host, take a look at the bandwidth in and out. It's a pretty pronounced effect. Before, right, 260 megabytes per second. That's saturating your wire and affecting everything else. After, nil, right? So what do you guys think? Is that cool? Right? By the way, also free, right? So if you upgrade, who here is a Clarion customer or a Solera customer? So if you upgrade to Flare 30, this is just goodness that appears. You got to be using vSphere 4.1. Who here is a Symmetrix VMAX customer? Anyone? Great. So this is coming in Ingenuity release that's very close, and in fact, it's running in the lab. So if you go to the EMC Hands-On Lab, you want to try it, you can see for yourself. Expect it in Q4 is my official, and come to me afterwards, I'll give you the exact date. Off the record. I did not say that. This is what it looks like on the ESX host side. These are commands per second. So there's actually upside here for the ESX host and the array. So it's goodness all around. Very significant improvements. And this is just getting started. There's going to be a lot more in vSphere to come as well. So, what do you guys think? Cool? I know everybody's like you seem a little, no coffee or, All right. Next, DRS for storage. So this is pretty cool. We think that everybody in the industry is going to need to auto-tier. The idea of auto-tiering is very important because solid-state disks today offer, in dollars per IOP, they're roughly 5 times better than anything else, right? Dollars per IOP. They're in absolute terms, they're much higher. The problem is that their capacities are small, right? And in terms of dollars per gig, they're not that effective. So what we've got here is we're moving to models where you just create a big pool that doesn't have one disk type, it's a mixed disk type. Now, DRS today does 2 things for CPU and for memory. It does VM kernel admittance, right? You know, like how much time you get. By the way, what I'm doing here is I've got an Oracle workload running. This is production Oracle, right? You know, 16,000 transactions per minute. And for those of you that were in the EMC super session, we showed it. Here I can explain it in a little more intimate detail, right, than in the super session. But basically, the DRS, and now what's happening is a developer is kicking off on the same ESX cluster another workload, and the code's poorly written, and basically it's going to BAM the array, it's going to BAM the network, it hits everything. So that you can see that the production Oracle servers transactions per minute are dropping because the other one is hammering the same underlying data store. DRS, the idea of kernel admittance, so in other words, how much time slice you get on the individual CPU, right, now exists in vSphere 4.1 in the form of storage I/O control, right? So you can go in, and this works with anybody's storage. You can go in and you can say, hey, I'm going to throttle that VM to only be able to do this number of IOPS, right? So this is the equivalent of giving it less, basically enforcing limits on for memory and for CPU. And what you can see here is that the one on the bottom is the dev box. You can see that its transactions per minute just went boop, right, because it's being throttled. And you can see that the prod box is climbing back up to a healthy state, right? Very important in the VDI use case, as I said earlier, and I'll explain why in a second. Now, the second thing that DRS does is it moves VMs around in a cluster, right, to optimize the whole resource. The storage equivalent of that is an automated tiering motion. In other words, taking that VM and moving it up or down, right? This is now a GA feature, right? Again, it's part of that Flare 30 Dart 6 release, where previously I had set this up, and the reason I didn't have, the default, by the way, is auto tier, because we think that that's just how everybody's going to do it. I intentionally turned it off so that I could show before and after, otherwise it would have already been distributed, the way that it would have looked like, because it would have done automatically. But basically what happens is that once we say go, right, you can take a look at where the data currently sits. And by the way, for those of you that are clearing customers, notice how fast Unisphere is compared with Navisphere, right? So we've been listening, simplicity and ease of use. We've been working hard on it, and I get to play with Unisphere v2, and it is the bomb. Unisphere v1 is awesome. Unisphere v2 is going to take the world by storm. You can see that what it says based on the I/O profile, I need to take 265 gigs of data and promote it to solid state. So once we say go, right, and remember this by default would all just be automatic. We switched to manual so we could see a before and after effect, right? Off it goes. And now if we go back and say what's the effect, the effect, of course, is that the VM that was on the prod VM, right, is going to accelerate. And the key thing that's important to understand is that we didn't change the data store characteristic. This is happening at a small level of granularity, right, at a block, an extent level of granularity. And you can see that, the transactions per minute, I fast-forwarded the dial here to fit in a super session, right? This is time collapsed about 10 minutes worth of time. You can see that basically the transactions per minute are going up and up and up as the storage moves from one storage tier automatically to a solid state tier. And by the way, if the workload it said, hey, I'm no longer hot, it would get demoted, right? So the core idea here, right, is storage I/O control does the first part of what DRS does, which is kernel admittance and throttling, and storage level auto tiering does the second half of what DRS does, which is vMotioning based on policy. In storage land, that's auto tiering based on policy. Does it make sense? What do you guys think? Is that cool? This is a very important idea, right? Because we're trying to make it a model where you do not provision storage the old-fashioned way, right? So, next. What are customers asking me when they're deploying desktops, right? In desktop land, this is basically an interesting study that says, are you or are you not going to deploy and when, right? And basically, no projects planned or pilot projects planned are the biggest things in the chart. Notice from year to year, there hasn't been a lot of progression. So there's some ouch here, right? Ouch, for adoption of this space. It's difficult problems. I mean, there's lots of customers doing it, and I think with the stuff that was launched today with Vue 4.5, lots of improvements, right? But one of the barriers, one of them, is the cost to serve the client, right? And the storage cost is a very significant portion of that. So we've been working on that hard, right? The first one is lower the cost of storage a lot, right? How do you do that? On the capacity question, right, it starts with this math. 100 users, 100 gig per desktop, 10 terabytes of storage, right? No, that's not right. There's many ways of solving this problem. One, Vue Composer, right, can help. It's not uncommon to see very high, 60-to-1 kind of storage reduction models for the non-persistent use case. In the persistent use case, it's generally a little bit lower, but it's still good, right? It's not uncommon to see 2-to-1 to 5-to-1. The next thing is if you take applications and virtualize the apps, this can be a very significant space savings as well. So that's how you can save a lot of space, and it's a beautiful thing to just throw the executable on an NFS or on a NAS-based device, and when you update it, you just update the file. That's goodness. My team uses thin-apt apps of everything within EMC. We've got them all internally. And then on the storage side, things like deduplication and compression capabilities can help here as well, right? So good places to use dedupe. Who here's a Solera customer? Okay, so have you guys been using the Solera dedupe function for file systems? So feedback? Real good? Oh, that's fantastic. So eventually, guys, deduplication, again, there's other folks in the space to do this. NetApp certainly does it. There's startups that are doing these sorts of things. There's deduplication in targets and for backup, data domain, all that sort of stuff. Eventually, more and more, you're just going to see data deduplication and compression become pervasive capabilities across the storage landscape. Just like we think auto-tiering and those sorts of things are become pervasive, right, to make this efficient. Now, what about the problem? Have we solved it? Great, we saved you a lot of capacity. Well, fantastic. If we do get 10-to-1, that means those 100 users can run on 1 terabyte, right? Wrong, right? This is a complicated conversation. The reason for it is, well, 1 terabyte fits on 1 spindle, right? So you can put it all on 1 big SATA spindle. Those 100 users are going to be happy? Oh, no, right? So people don't naturally think about this, but how many people are here in the room, rough and tough? I don't know. 80 people, 100 people? How many hard drives do we have in the room? Probably 120, the ones in our laptops, the little USB ones, all that sort of stuff, right? So if we put all of you guys, we virtualized all those and we put it on an array, how many spindles would we need? By default, probably something around 120, right? Because right now, all of your hard drives are pretty idle, but there'd be periods when they'd all be really busy. And now, maybe it's not 1-to-1, but it's certainly not put it on 1 or 2 or 5, right? So what are we doing to solve this problem? The idea of large mega caches is also in our view, going to become a pervasive idea, right? So the idea here is right now, the arrays have got a cache that can buffer up a lot of the IOs, right? What we've introduced in G8 is the ability to be able to just add a solid-state disk non-disruptively and go, that thing is an extension of system memory, right? So normally in a mid-range array, caches in the order of hundreds of megabytes to small gigabytes, right, is normal land, right? These mega caches mean that you can assign up to 2 terabytes of solid-state as an extension of system memory, right? And again, solid state, everyone gets into debates about where's it going to live? Is it going to live as volatile, non-volatile storage? Is it going to exist as a cache? Is it going to exist in the server? The answer is it's going to exist everywhere, right? Again, solid state, a lot of people, we screwed up our marketing when we launched it. And we've been selling it now for about 3 years. All that stuff about where and that's all a load of hoo-ha, right? Yes, consumer drives, when they first GA'd, had problems with performance change over time. Even in consumer land, that's no longer true. Who here has a solid-state drive in their laptop? Are you happy? Would you like to switch back? No. You'll pry it from my cold, dead hands, right? So that reason is the reason that, you know, the prices are dropping like this, capacities are going like this. Our estimation is that around 2013, it'll actually be cheaper even on a dollars per gigabyte. The watts per IOP are 100 times lower, right? So eventually solid state is just, everybody's going to have to do it. Everybody, server in the array as cache, as a target, right? Now, the thing that is also important to understand, though, is that people think of it as expensive. And our marketing originally was 30 times faster, 10 times more expensive, right? Which immediately made customers go, what workload is worth, you know, that level of performance, right? And some of them do in the finance vertical and the genomic, you know, literally if you can do the transaction faster, man, it's a bargain. I'll save boatloads of money, right? For most customers, however, they immediately went them go, yeah, I'm not that interested in that, right? Through the magical power of mathematics, watch this. Would you like to have the same performance at 1/3 the price? Yeah, that sounds a lot better, right? So the point is that measured in unit IOPS, they are significantly cheaper. So take a look at this. The idea here is it exists in all three use cases, and we've done a boatload of testing. This documentation just got published today to support the View 4.5 launch. This is what it looks like. If you assign a solid-state disk as an extension of cache, red line is no mega cache. The blue line is with mega cache, right? We can basically reduce the number of back-end IOs during this boot storm period from 232 to 13. That's 30 times less, right? And that's the difference between this latency. Let me grab the pointer, right? This latency chart here, bad, right? And this one here, which is good. It's a read-write cache. And this basically says how much of the IOs were being absorbed by read cache effect and how much by write cache effect, right? So really cool, huge savings, right? So it's, again, it's bad for us to say, hey, this is faster. This allows you to deploy storage cheaper, right? Otherwise, you would have needed 60 spindles to absorb this IO workload because we were doing 13,000 IOPS during that time period, right? What about recompose activity? So again, before and after. 224 back-end IOs per disk down to 59. That's 4x cheaper. You can deploy it with 4x less, right? And the actual task got faster. This is what it looks like if you do an antivirus scan. So it's not just about deploy, boot. It's about these processes, the parts of the life of a desktop. So this translates into my client is so non-responsive that I think it has crashed, right? I'm going to go get a coffee, right? It's a huge improvement to the end user experience as well as actually reducing the cost of the infrastructure. And this is what it looks like when you're doing patches, right? 2 times better across the board. The net looks something like this. The old-fashioned way, the new coolness way. Right? A lot less power, space, cooling, cheaper, right? And the things that we use there is we used, View 4.next, which everybody now knows is View 4.5, right? We used EFDs for the base image. We used fast cache to absorb those IOs. We used VAAI to help with the metadata updating. That's how all those things fit together. A better way to put it, and by the way, there's a lot more to this desktop use case than just storage. So we're working on those things too. There's a secure book for View. One thing is around how do you do backup and recovery. People want it so the users can recover the stuff themselves. So there's a end user self-restore thing. Creating one thing that people are asking us for is they want it as a single SKU, so that as part of the VCE effort, there will be a VCE reference architecture for View 4.5 and migration services. So we're looking at all of these things, but today's a storage discussion, right? So we're putting our money where our mouth is. This combination, we're saying, hey, there's zero risk. But we'll go a step further and say we can do it for as low as $38 per client, right? So there's a document out there that describes how we did it, what was the config, and that was at a scale of 2,250 clients. If you're larger, it gets even better, but it can also scale lower. Okay. Now, what do people ask for if they're a service provider? And I want to make sure I get through this stuff so I can take any Q&A that you guys have got. I know I'm running behind schedule. So the questions that they ask are very different than sometimes we get directly from our customers directly. So for transactional storage, they want scale out everything, and fail never is a requirement, right? The reason scale out is really important is because they don't know what their future demand is going to be, right? They have no clue. They have no baseline, no anything like that. So they need models where they can scale out, and management at scale becomes really important. In other words, how easy is it to have less FTEs, full-time equivalents, managing larger and larger amounts of storage? Efficiency matters, but different things are critical. So things like thin and wide are important. Why are thin and wide important? Because they want to be able to make sure that they're going as wide as they can across the back end, across the ports, along the brains, because they don't ever know where a point of hotspot will occur, right? And that's the best way to defer that across their customer base, the user base. VMware integration still matters, but in slightly different ways. They don't care as much about vCenter plugins and things like that, but they still like them, right? Most of all, they need stuff that supports their business model, right? So they look low dollars per gig in the CapEx-oriented model. The current kind of bar here is about $2 per gig, because $2 per gig as a consumption on the capital allows them to sell it for about 10 cents per gig per month, right? And they also, if they're small and they don't have a lot of capital, they like OpEx models where they say you need to sell it to me on a utility where it's like 8 cents, a gig per month, right? Because then I can sell it for 10 cents a gig per month and make my 20 points of margin that I'm aiming for, right? They want to be able to go low because they know that in the public cloud use case there's this expectation of low cost, but they also want to be able to go higher. They want to be able to have a bronze but be able to reach out to you and say, well, I can also offer you encryption. I could offer you a gold. I could offer you replicated, those sorts of things. So they also ask for something else that's weird. So the best way for me to explain this is like this. They say, I need to build infrastructure as a service. I'm going to use vCloud Director, and I'm going to need to have some sort of storage, and I'm going to basically add ESX hosts as I get customers, and if I need to, I'll add another array. Notice how I've said SAN or NAS models today. This is how this works. The other thing that they say is sometimes they go, I don't really like that one because this isn't a scale-out model, right? You know what I mean? If they had a customer that was really hot over here and they had excess capacity here, it's hard for them to balance it out, right? So they tend to prefer this model where they go, I'll add lots of things like that, and as I add more clusters, I'll add more brains and more ports and more disks, and I'll scale out. How many of you guys are following the whole 3-par thing? Anyone following that at all? The reason that all this stuff is going on is because their model looks like this, right? So, whether it was by coincidence or by design, it's a well-suited architecture for that sort of model. EMC's answer down that path is a VMAX. A VMAX is a cluster of a commodity x86 brains, right, that are attached up to 2,400 back-end disks. It has a name, Symmetrix, which is associated with platinum, right? But architecturally, it's a cluster of commodity x86 servers, right? And we're doing very, very well in that particular segment of the market. But the thing that's weird is how many of you guys use Facebook? A lot of people, right? Facebook, in a busy week, would ingest 70 terabytes of data, right? Just people uploading pictures. How much do you pay to use Facebook? 0, right? And when you click on the picture, right, how do you access it? You don't access it by, whack server name, whack file name, right? So it's not a NAS. You access it natively as a web object, right? http:// blah, 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 right? Now, how were they doing that originally? They were putting it on NAS and had, web servers in front with, databases that correlate all that stuff, but that is a lot of management complexity, right? And there's many, many examples of that. Has anyone done a twit pic in the last, couple of hours or days, right? All of those things, when they go on there, they go onto Amazon S3, right? So those things, this idea of just huge scale-out, object-based things that natively present stuff instead of via NAS or via SAN, but as a web object, is an exploding area in storage land. And what those look like is they look like servers with DAS that have software that just gloms them together into a giant object pool, right? In essence, there's no real file system. It's not block. And you natively just go put in an object, and the object can have an object level policy. So it's not a file system level policy or a LUN level policy. Does that make sense? So this is a very interesting emerging area. EMC does all three of these things. This is our EMC unified platforms. This is our scale-out VMAX model, and this is an EMC Atmos. And we're bedding down all three of these paths because they have distinct and different use cases, right? One thing that's interesting that I'll talk about in a little bit is you can actually get Atmos as a VM, right? At scale, it makes sense to have it as an appliance, but you can also just sprinkle on an Atmos to an existing array, right? So this one tends to be a very common architecture in private cloud view use cases, things like that. This one tends to be common for very high SLAs in private clouds or scale-out commodity public clouds. This one tends to be the common thing for next-generation apps. If you're writing an app in Spring, you're probably looking to use some of this funky storage on the side as opposed to more of the traditional storage models. Does that make sense? The problem is that these storage models have latencies that are measured in hundreds of milliseconds. You know what I mean? And that doesn't work for this use case. I often get the question about why do I say SAN NAS and SAN here today. The reason for that is that today on vSphere there's no scale-out NAS. It uses NFS v3, which means that a data store always lands at the end of a single IP address, which means that even if the NAS could do a scale-out abstraction, you in essence can't scale it out. And that scale-out requirement was one of the ones at the very top for the service provider use cases. Now, so this is what Atmos looks like, and I've got a quick thing just so you guys can visualize this. So, has anyone gone to Virtual Geek? So, we've got a problem. Chad's army out here, you guys out there, the V specialists internally are putting stuff on an FTP server. There's about 100 terabytes worth of storage on there now, right? And we had an outage that actually caused a lot of links to get busted and stuff to disappear. We also have a problem. They're around the world, right? They're all accessing an FTP server in Hopkinton. So what we've done now is we've migrated it over where you have this Atmos master node, right, which is a VM. And these ones here are slave nodes. As soon as you put them in, they go, hey, where's the master? And then they do like a Pixie self-install. So you can scale out as many nodes as you'd like. And we've done the same. There's one in Denver, Colorado. We're putting them now on traditional storage. So this is the sprinkle object on traditional storage model. But of course, you could have this object model exist, on just DAS or whatever, right? So we've got Site 1 up and running. Okay, cool, fantastic. That's this one in Colorado, right? And this is basically a little clustered grid of object storage. So now in EMEA, we've put up one in UK, right? And fantastic. This thing is now up and running. The key thing is that you can set up policy, not where you replicate everything, but the policy occurs on the object, right? So as we dump in something, we go, this VM needs to be distributed around the world. This VM can be just in the Americas, right? So simple, easy. You can install it fast, and by the way, at the end of the show, we'll be putting on Atmos just for anyone can use it, like go to town, right? So a neat thing, and it's pretty cool to set up. This is what the UI looks like, and it's natively multi-tenant. So you can, it obscures out the idea of what tenants do I have, and the vSpecialist can assign, you can create multiple tenants directly in the storage. In this case, it's not like there's vCloud Director on top. The multi-tenancy needs to be built into the storage. For the transactional use case, there's multi-tenancy provided all the way through the stack via vCloud Director. But here there's no vCloud Director on top of it. And then you can interact with it via all sorts of APIs. There's APIs, people have written iPad apps that use Atmos. Here, in this case, we've got an application that's a plug-in for Firefox that makes it look like FTP, right? You drop stuff in, and when you drop it in, you give it the metadata, and then off it goes. Now, the thing that is cool, though, is that eventually what you end up with is not a file. So again, it's not whack path to on FTP server, right? Because that's a management problem at scale. What you do is you basically end up with a URL, right? So the thing that's also very cool about this is that AT&T is offering a service based off of Atmos, and you can federate to it. So you know that vision of private public cloud hybrids, we're not just doing that for infrastructure as a service, we're using that for cloud storage models. So here what I'm going to do is I'm going to take that, I'm going to say, okay, great, let's add an account where we'll federate this directly in AT&T, which means that, hey, not only have I got my stuff in Boulder and in Denver and in the UK, I'm using AT&T as a service. And you can take that, give me a URL from the object. This is actually now on AT&T's Synaptic service, and that means that you can just stick it into a browser and you get the stuff. This is the file that I stuck in there. Does that make sense? You can see that this is a model that is very interesting for next generation app design, right? Which is why it's very, very important in storage land. So that's all super cool. What does tomorrow look like, right? This is all stuff that is not science fiction. This is all, shipping, GA, today. But you come to VMworld to get a little bit of what's tomorrow, right? What's tomorrow here, and these are areas of advanced R&D. Number one, can we make object models look transactional? Because that would be cool, right? So there's multiple ways where we're trying to do this, because the thing that would be cool is there's no management model that's needed underneath. There's no file systems, no LUNs or anything like that. And policy can be done on a per VM basis. So we could make all of that stuff apply in the vApp directly, right, and correlate right down the storage. The problem is that 100 millisecond latency thing. So could we use a distributed cache layer in the ESX host model to, abstract that enough to make it good enough that you could host VMs directly on it for transactional use cases? That's one area. By the way, did anyone go to Jay Judkowicz's or Kumar's session? So if you haven't, I think they're repeating it. It's TA8218, where some of the things that I'm describing in here, you might have seen reflected in Jay's session. It's what VMware's thinking storage look like 3 to 5 years out, right? Storage policy is very important, and can you make it so that the policy is controlled by VMware and the storage just does it? When you create the VM, you go, I want this VM replicated on, every 5 minutes locally, and that's my backup, or I want to replicate it off-site and my RPO is X, right? It needs to be gold, and all of that stuff is enforced first at the data store level, but also at the VM level. Storage, I/O control, and auto-tiering, the thing I showed you, is just the beginning of that, right? There's a lot of work going down that path. The other one that's interesting is, I don't want to give away the farm here, right? But basically, two years ago, we made a huge bet. The huge bet for us was, look, everything x86 is going to win, right? Which that turned out to be a good bet, right? x86 is winning more and more and more every day. The challenge for us was we also made the observation that goes, holy smokes, like it's not uncommon today for an ESX cluster to have 190 cores, right? 192 cores, call it 200 gigs of RAM, with 10 gig interfaces coming out of every blade or every rack mount host. And that's going into an array that has 8 cores, right? And has, 128 gigs of RAM, and has, 8 interfaces. We're like, uh-oh, right? If you look out a little bit, Westmere EP is out. People are now building new ESX clusters. vSphere of future will increase, various limits. It won't be uncommon to have huge resources on the ESX side. How is an array going to keep up, right? So we said we need to absorb massive multi-core. Currently, EMC storage arrays, if it's a unified array, would have roughly around, 32 to 64 cores in it. The next generations are going to have 192, 256, huge numbers, right? Because we need to just keep up with what VMware's generating on the front end, right? The reason that we made the modular I/O model was because, A, we knew people were going to be moving from 1 gig and 4 gig fiber to 10 gig Ethernet and native FCOE, and we were like, they need to be able to non-disruptively change that, right? And be able to have huge port densities, right? So we support, basically on a big array, you could have hundreds of 10 gig E ports. So the thing that is a question, though, is now that we made the bet that says every single EMC product runs on the exact same commodity x86 hardware, how are we going to leverage 192 cores? We're going to have to virtualize our own assets, right, so that they can scale out to be able to leverage that sort of thing. The early versions of that are in the idea of, hey, you can download a Solera off the internet that's a virtual machine. The Atmos thing I was talking on is this sprinkle on the VM idea. Now, in certain scales in economics, having the sprinkle on is good, right, if you're smaller. But at larger scales, it's less effective, right? It's sometimes better to have a dedicated purpose-built design. But expect to see more and more on this idea of how do we make it easier and easier to add value and make it simple and easy to leverage. The other one is that you remember how I said the scale-out NAS model today at NFS v3? A lot of work around continuing to mature the scale-out NAS and PNFS models, right? So in other words, what do we need to do to add that into the VM kernel? What do we need to do to make sure that we support PNFS? We actually support PNFS today. But how do we make real scale-out NAS work more commonly across a broad set of use cases? Because again, I saw the ratio of block and NAS. I think that more people should be using both, personally. That's my personal opinion. And then the other one is federation. So you saw this in Jay's session, right? The idea of, look, eventually all storage is going to be able to be geo-dispersed in active models with various presentation modes. For EMC, this is vPlex. By the way, for those of you that weren't in the super session, it was pretty. Did you guys think that was cool? I hoped AT&T was not in the room. I wasn't actually saying. So the comment there for those of you that weren't present is we were doing vMotion across distance. And vPlex creates an active storage model. And we stuck a latency simulator in the middle for both the network and for the storage network. And we basically dialed it up higher, and higher, right? Eventually representing going from hundreds of kilometers to thousands of kilometers to 2,300 kilometers. But it's not really kilometers, it's latency. By the way, what I didn't show in the demo is we tried to do it to San Francisco, which was 80 milliseconds, and it totally barfed. So we elected not to show that one, right? Still some work to be done, right? And that is not a GA capability today. Today we support synchronous distances only. And there's some good KB articles from VMware and EMC about how does EMC support stretched clusters and vMotion across distance. But the thing that we're thinking is, really, we've got to make this much broader use case, much longer distances. We've got to make the maturity of stretched HA much more mature, right? And ultimately, we think that that's something that needs to be done in a lot of places because, that vision that Paul put up there, federation of clouds, those sorts of things, we're going to have to crack that nut, right? But again, you can see in here that we're not smoking something when we talk about it on stage. These are areas where we're delivering on those capabilities today and we're investing a boatload of R&D for tomorrow. So, by the way, like I said, if you haven't gone to Jay's, I'd highly recommend it. You get a good perspective on what VMware's thinking. So, I'd love to take any questions. I know that I'm basically at time, but I appreciate you guys sticking around. Unload. What questions do you have? There's a mic there in the middle of the room. And don't be shy. And if you need to leave, again, forgive me for actually running over schedule. So the question was, just to repeat it, right, is that storage I/O control throttling the closest that you can get to QoS on storage, right? And it was actually a really funny engineering meeting where we were like, well, we could do that in the array. We've got these QoS mechanisms, and we do, right? We can prioritize CPU, cache, partition it all, and all that sort of stuff. And basically, the VMware guys were like, yeah, but no one's actually really doing that. And it's because doing it at the storage level has never really been that successful in the market because it's complex, difficult to figure out, difficult to tune and dial. And SIOC has already had more market success, in my view, than the stuff that the array vendors have been building for a long time, right? So it does actually deliver throttling, and there's also the idea of shares, just like what there is with memory. So you can assign a share, and the share values give relative queue admittance, for the various VMs. It's just the beginning. right? So there will be more down the path of what VMware is doing, but it actually does deliver a pretty good QoS experience on storage today. I think people are going to start to use it more and more and more. One thing that's interesting that people don't naturally think of is it's huge in the View use case, or the VDI use case even more generally, like if you're doing Xen on top of VMware, right? The reason for that is that on a desktop, right, or a laptop, your hard drive is never going to go faster than the one hard drive that you have. So it's not like you going to town can affect me over here, right? But when they're shared on the same subsystem, there's nothing stopping you from doing 10,000 IOPS, right? So one thing that's interesting is in early testing, what we're recommending is we're saying, look, just assign a storage IO control threshold of 80 IOPS per client, right? And that way you can make sure no one spins out of control. Yeah. Any other questions? Oh, that's a great one. So the question was, well, again, perhaps dry for others, but not for me, and I think it's cool. The question is, what about APIs in the storage to facilitate, different ways of managing, automating, those sorts of things, right? So basically, we've made huge investments down this SMIS path, and SMIS has never really kind of taken off, and we think it's because, for the most part, a lot of the providers have been kind of weak, right? The SMIS support that we've got now is very strong, and it actually has a PowerShell API. So if you want a PowerShell API to our stuff, that's now GA, which is step one. Step two that's interesting is we haven't formalized the API yet, but one thing that we've heard from the application owners is that they would find the fast data very useful, because for the fully automated storage tiering, there's a whole bunch of metadata that we're tracking inside the array about how data is being accessed and used and what's hot and what's cold. And the people who do optimizations at the database layer and things above have said, hey, if you could give us that stuff in various ways, that would be useful. We could do optimizations higher up in the stack. That has not been formally opened up yet. We are proposing it as an API standard. So, and the thing I'd say is I think more and more people need to start using both PowerShell and SMIS. You can do everything on our arrays that way, and it's pretty simple and easy, and the commandlets are pretty straightforward. Our first version of our PowerShell kit GA'd, I don't know, a month ago, and we're already working on version 2. Does that answer your question? Any other thoughts, comments, questions?
Concerning the AI and the hardware off all those APIs,
Mm-hmm.
what's the short or long-term impacts on the scalability of an array which was built and manufactured before these APIs came along? Granted, the array was built, maximum IOPS.
Yeah. So the question, just to repeat, is what's the impact on the array from these hardware assists, right? And what should I expect? The thing that's been interesting is that you'd think that if the work is moving from the ESX host, it has to move somewhere else, right? What we found is that for each one of the offloads, there's actually decreased storage processor utilization. There's actually decreased back-end IOPS, right? So it's a net win on both sides. So far the data, and we've been hammering on it for months and months and months now. The fact that we GA'd it, what happens within EMC is we GA stuff usually a month internally, and before it gets GA'd publicly. The testing is showing that there's actually a net reduction across every aspect. So we're not anticipating anything, Jason, that suggests that there's any negative impact whatsoever. Yes, please.
With that said, does the VAI support, will it support DMX4? And if so,
that's a great question.
Is there a benefit for storage migration? So we've got a bunch of DMX4, we just got a bunch of DMXs in, want to do storage motion migrations, then
that's a great question. So unfortunately, there will be no VAI support on DMX4, 3, or on CX3 or earlier. The reason for that, guys, I know that I wish that I could say something else, but the reason for that is that when we went from the DMX to the VMAX, it went from being PowerPC to being x86. the kernel is totally different, right? You will increasingly see all new features being very focused on. So there's times where a company needs to make architectural boom. And one thing, we did a pretty good job of actually making them look like they're the same, even though the underpinnings are totally different, right? But unfortunately, people don't realize that for us, the engineering effort to try and backport it is immense, right? And unfortunately would slow down innovation going forward, right? So I know that that's not the answer that every customer would like to hear, but it is the truth. Likewise on CX3 looks a lot like a CX4, but it went from a 32-bit model to a 64-bit model. Totally different kernel, right? And by the way, if we hadn't done that, we wouldn't have had enough 64-bit memory space to be able to do stuff like auto-tiering and fast cache and whatnot. So that's the first part. The second question is, what about array-to-array migrations? So first things first, we can do non-disruptive federation today via vPlex. You can stick a vPlex in the middle, move everything over, and then either leave vPlex in or take it out, right? Second thing is you can expect to see more from us around federation. We know that the single biggest pain point for big customers is the array swap, right? So what you should start to expect to see from us is that the ability for storage to non-disruptively move from one array to another will increasingly become a pervasive natural attribute whether you have vPlex or not, right? Now again, will that help you from the DMXs to the VMAXs? No. It will help going forward, right?
Where can we read more about that $38 user 245?
On Virtual Geek, of course, right? It has the layout, it's got the configuration, it's got all of the elements, it's got the testing. Now the thing that I would just, guys, say is when you read my blog post, I'll give you a little bit of the shortcut. There's a bit of marketing involved there, right? So it's a real workload, right? The problem is that every user varies, every customer varies, right? So the front end question that matters the most is what's the IOPS workload, right? This was 6 IOPS, which I would describe as a light user. When you read the doc, it'll say light kiosk, blah, blah. There's some, no one's hiding it. There's a similar reference architecture, they're paired, because what we knew we needed to do is say, look, we can be as efficient as the next guy. In fact, I'd argue we can be more efficient. But then we also said, you know what, let's show how the exact same configuration can be scaled up, right, to support 20 IOPS per client, right? And basically that heavy workload reference architecture document is also posted. And it basically has a slightly higher price point because we've just added a little more EFD. We've added a little more, a little more SATA for persistence, right? But all of the principles are the same. And that's one thing we wanted to really aim on this reference architecture was to go, here's how as low as we can go. That exact same thing, you turn up this dial, and this dial, and you can deal with bigger and bigger and bigger user workloads. By the way, we actually did the math. It was about $50 for a 20 IOPS client, right? So, it's not like it's wildly different. That's all the storage stuff, right? So everything in on the storage side. That's an interesting question. So, the question was, why couldn't you expose it even higher, right? And say, if you presented a virtual disk directly to the guest, be able to do a hardware accelerated motion between guests, right? Copy of data, yeah. So what's interesting about it is now I'm going to totally engineer out, right? The way that those got implemented is via SCSI commands. SCSI write same, SCSI extended copy, SCSI, compare and swap, right, which is the one for the other one. There's a bunch of other ones. So trim, right, is part of that whole process. And the whole storage industry is moving towards a model where those APIs are going to be eventually embedded in every OS. But it has to exist in the OS, and it has to exist in the array to be able to do it, right? So first things first, there's the debate about breaking encapsulation models and presenting stuff in the guests, which in general, has downsides. There's some upsides too, but there's some downsides. But eventually what you can expect to see is that within NTFS, as an example, right, the right now you got to do delete commands and stuff like that to recover space. As soon as they support those write same, trim, models, it doesn't matter whether it's done at the guest, we'll pass those through the VM kernel and you'll be able to do those same tasks. You know what I mean? So that's how we're going to do it. But it has to exist in the OS. It has to exist in the kernel. Any other questions? Yeah, so on a Solera, compression, so basically dedupe occurs on a file level, which in the VMware context applies to stuff in guests, it applies to NAS. In NAS land, it's awesome. It's very efficient, saves a lot of money, but on VMDKs does zilch, right? So in the VMDK use case, we don't expose, dedupe as a button, right? The only option in the plugin is compression, right? Again, I can't say specifically, Jason, on the record, right? But you can expect to see more and more pervasiveness of deduplication across everything, and I think across the industry as a whole, because clearly block-level dedupe is a good thing, right? It has upsides and downsides, but there's certain use cases where it can be effective. Now, the thing that I would say is that over time, what we're going to need to do is we're going to need to expose, dedupe, and compress. That's not what we want long-term. Long-term, what we'd like to do is we'd like to make how the deduplication is occurring, whether it's a file-level dedupe, a block-level dedupe, or a compress, something that is automatically switched based on the data. Right? So there'd be some contextual thinking about what's the data look like, which one of these techniques should apply the best. We cannot do that today, right? But that's the target, because eventually we think these all get lumped together just into storage capacity efficiency, right? But unfortunately, right now, there's that extra layer of complexity. I don't know whether that answers your question, but...
So you mentioned some of the hardware-assisted capabilities.
Mm-hmm.
Do you have any other capabilities which are not being exposed because of hypervisor not exposing them to APIs? Or
There's boatloads. And all of those discussions resulted in the design for VAI v2, right? Which is well underway. The example, the first example is the fact that we can do a hardware accelerated file snapshot, right? So we, on those devices, the demonstration I did, we made it VMware integrated by bolting it into a plugin, right? The ideal way that most customers would want it to be exposed is it's just invisible. It's just faster. It does it on its own, but I go in and I do the snapshot the way I normally would, and if the array supported that operation, it would be exposed that way. That would be the, one variant. Another example is that, some of our storage platforms, and increasingly it'll be all of them, can support encryption, right? We think that data at rest encryption is going to need to become, over time, more and more of a pervasive storage behavior, right? Now, VMware is going to be over time is going to be adding encryption at their own stack. That's something that could be better handled and offloaded to the array, potentially, right? Particularly for data at rest, not data in flight. There's other examples as well, like that idea of federation as it arrives. The idea of federation, not with a vPlex, which we can do today, but federation is a natural part of what the platforms do. That could be exposed up that way. The list is really, really long. One other one that is interesting is right now storage I/O control and auto tiering are linked ideas and work great together. Ideally, what you'd like the auto tiering policy to be driven directly out of the DRS tab, right? So again, all of these things, you can kind of see where we're going and what we're thinking. Well, so the question, just to repeat it, right, is there a plan to threshold behavior, with storage I/O control, network I/O control kicks in on contention, what about storage I/O control? Basically, did I get it right?
Yeah, exactly. The ability to say, if there's contention for this, then this means
That's, by the way, that's exactly how it works. Storage I/O control does nothing unless the storage I/O control threshold is exceeded. The threshold, by default, I think is 35 milliseconds. It could be 30 milliseconds or 25. I need to look that up. But basically, and what it's doing is it's measuring guest response time, right? So if any guest in the data store exceeds that threshold, you remember in that demo there was that yellow triangle? The yellow triangle goes off, and then the storage I/O control throttling or share values kick in. In fact, even though the mechanics of how they're done are totally different, the way they look to you guys as a customer is very, very similar. Any other questions? Guys, thank you very much. I really appreciate it. Guys, it's my pleasure. Thank you.